So what we're going to be looking at here is something called the mole. Okay, so guys, in life we're either going to weigh or count substances in order to determine how much of that substance is present. So like beans and rice, you may pull them from a large bin, or you may buy them by the pound in a bag. Basically, we weigh these items in order to figure out how much we are purchasing. The other approach, obviously, is counting. So we buy a dozen eggs. Okay, so a dozen eggs, we know there's going to be 12 eggs in that package. So basically a counting approach. So in chemistry, guys, we're going to be using a special unit to count atoms and molecules by weighing them. Okay, and that unit is going to be known as the mole. And in order to understand the mole, let's go ahead and talk about some of its details. Okay, so what is the mole? Okay, so guys, the mole is an SI unit for the amount of substance that contains the same number of chemical species as there are in exactly 12 grams of carbon-12. So basically, the mole is referenced from the most abundant isotope of carbon. Okay, so that reference point is what is used to establish the moles of a substance. Okay, so it's a reference point relative to another atom type. Now, a mole, guys, is always going to contain the same number of chemical species, and that's going to be related to Avogadro's number. So 6.022 times 10 to the 23rd is Avogadro's number, and Avogadro's number represents species per mole. Okay, so in a mole, you are always going to have this number of species. So what do I mean by species? Okay, so I mean ions, I mean atoms, I mean molecules, I mean oranges, apples, whatever. If I have a mole of substance, whatever that substance is, I'm going to have this many of them. Okay, now this is obviously represented down here. 1 mole of carbon-12 is going to have this many atoms, Avogadro's number of atoms. 1 mole of water is going to have 6.022 times 10 to the 23rd molecules, so on and so forth. So when we say species, guys, we are referring to obviously this Avogadro's number, which is a constant. Okay, so make sure that you memorize this number, relate it directly to it representing 1 mole. And this conversion is going to allow us to interconvert between various substances. Let's go ahead and let's look at the relationship now between mass and moles. So the molar mass is the mass of 1 mole of a pure substance expressed in the units of grams per mole. Okay, so guys, basically what we have here is a relationship or conversion factor between mass and moles. Now, in order to get the molar mass for individual elements, we're just going to look on the periodic table. We're going to go ahead and we're going to look below the element symbol on the periodic table. If we were to look below gold here, we would see 197.0. Now, you may be saying that that's the average atomic mass. Yes, that's the average atomic mass. That's the mass of the element, and that's going to correspond to 197.0 grams for every 1 mole, all right, for that specific element. Now, diatomics, I just want to mention this really quick, should be treated like compounds. So, if I say, hey, chlorine gas reacts with, obviously chlorine gas has the formula as follows. So obviously there's 2 chlorines present there, so you need to calculate that appropriately. And we'll talk about how to do the calculations here when we talk about compounds. So molar mass of compounds, again, we're going to look at the periodic table. And what we're going to do is we're going to follow the rules that we see below. So what we're going to do, guys, is we are going to look at our compound. We're going to look at the types of atoms that we have and the relative numbers in the compound. So in this case, obviously, phosphorus, there's only 1 of them in this compound, and there's 3 bromines. So what we're going to do is we're going to take the number of phosphoruses and multiply them by the molar mass that we obtain from the periodic table for that element. We're going to add that then to the number of bromines times the molar mass of bromines. We're going to sum that together, and that will give us our molar mass. Okay, so if we go ahead, we see we have 1 phosphorus times the molar mass of phosphorus plus 3 times the molar mass of bromine. Okay, and that gives us our molar mass for our compound. So now that we have the tools to convert between grams and moles, as well as other chemical species per mole, using Avogadro's number, we can now move on to a more complicated approach to these types of problems.